have softwares to do this analysis. You just need to understand how to use the software. So the best way for you as a student is to get your way into industry by doing internship. Internship is very important. It is the only opportunity as a student you have to be able to get to industry, learn some things, and then get something on your resume. When you graduate school, every employer wants to see you that you have worked in a particular place. It can be 3 months internship, but of course you have learned something. And then also, I always advise people, when you are doing internship, use all the opportunity you have to ask the questions. Try to find a mentor or somebody at the workplace, and then get closer to the person, ask the person questions. And I used to do this a lot. I'm not talking about myself, but I'll use myself as an example. When I was in ECG, there's one of the engineers there is very, very helpful, very, very great. And I always remember him, Graham. Graham was always teaching me. I always go to him, he take things and then teach me things. I did not like protection so much when I was in school, but Graham made me to love protection, and I still love it. So try to get internship. If you don't get internship, try to get a national service in a very good company. And that's how you begin to build relationship. Sometimes getting employment after even national service is not guaranteed. I did my national service in ECG, but I did not work in ECG. At the time, what the job that was available for me, I was lucky I got into power generation. So my advice to you is that don't leave yourself for free. Don't leave yourself like things will happen magically. You need to take the step, get internship, and then try to learn from people, try to get involved. I think that is the advice I'll give you. So let's try to see that maybe we don't exceed the time so much. If you have other questions, the presentation here, I think, is recorded. Yeah.
Yes. I think we allocated 30 minutes for Q&A.
So,
we did that.
okay. So we allocated 30 minutes. So it's
let's take a few.
Okay,
from
we are
I
now
think there are
past 2 minutes.
Yes.
Okay, we can take some additional question up to the 8 minutes, and then we can close. One thing I want to say is that the PowerPoint presentation, I'll put it together in a very good form, and then I'll PDF it, and I'll put it on my blog website. You can actually get it there, or maybe I'll post it on LinkedIn. You can download it on LinkedIn or download it from the website. Okay, let's see if somebody has a question. We have, I'm giving additional 8 minutes. Okay, let's see. I'm going through to see if somebody has a question and we can address that. Okay. Okay, yeah, the question somebody has is, can you please share the PowerPoint PDF? Yeah, that's what I said. So I'll share that. Right now, I'll put it together in a way that is more presentable. Maybe add a few notes somewhere else, because in the PowerPoint you don't want to have a lot of words in the slides. And then I'll PDF it. I'll put it on the website, shylearning.com. You can always download it from there. I have additional things on power systems, stuff you can download from there. Yeah. Okay, I think if nobody has a question again, I want to say thank you. Idrisu, you can take it from here and then bring close to the end. Yeah, I'll put the website here, shylearning.com. Okay.
There's actually a question in the chat from Otrejan. He says,
okay, can you read the
PLC,
question?
PLC focusing on ladder logics. Does PLC really play a big role in the energy sector? If yes, how?
Yes, PLC is very important. So this is the website.
Say I'm into PLC.
Okay, let me read that question. It says, the PLC focusing on ladder logics. Does PLC really play a big role in energy? Yeah, PLC plays a very, very important role, even in power generation. So as you know, PLC is a programmable logic controllers, right? So these programmable logic controllers, for instance, when I was working in the power plant, we use Modicom quantum PLCs from Schneider Electric. So you have the PLC taking signals or information from the site, the field, the sensors from the site. A lot of devices measuring temperatures, pressure, and even a lot of signals, current, voltages coming in. All of these signals are input into the PLC. And then based on that input, the PLC has been programmed to take decisions. For instance, let's say you want to measure the fuel, the temperature of the fuel. And the temperature of the fuel should be, let's say, 40 degrees Celsius. And you put in the logic that, okay, if the temperature exceeds 45, give an alarm. So the control room operator will take action. Okay, the temperature of the oil is going up. It means that it needs to be cooled. And so if it needs to be cooled, what is the next action? Maybe the PLC is actually programmed to make sure that the closed circuit circulation of maybe fresh water, or maybe the radiator from there's a radiator actually providing cooling to this. We'll have to increase speed. And so in simple and short, PLC is very important. It's used in usually in power generations. It's used in manufacturing process because it takes input, based on the input, take decisions, and then the decision will either be correction, or at worst it will send an alarm to a control operator, and the control operator will take decision. And if nothing is happening at all, it will go into the next stage that the PLC might send another signal to take the device out of service, or maybe shut down the plant. So in simple and short, PLC is very important skill to have. It's under automation. Okay, I think that's the last. Somebody asked.
Yes, I think that's all.
Okay.
Say you go ahead and take that last one.
Okay, I think that's all right. So we'd like to, yeah, Idris, you can bring the program to an end now, and then
Okay.
thank you all for coming. Yeah.
Well, I'd like to thank you all for those good questions. I think the end of the Q&A will actually close us. So this brings us to the end of today's session. On behalf of the entire Student Energy chapter, I'd like to extend our heartfelt gratitude to you, Engineer Shaibu, for honoring our invitation and giving us a deeply insightful session. And to everyone who joined us, thank you for making the time, and let's keep engaging, sharing ideas, and building the energy future we all dream of. So until then, stay curious and passionate. Thank you and have a great day.
Thank you. Bye-bye.
Bye.
When it's all said and done,